Hello everyone. So today I am going to explain you about our project, final year project, which is Alzheimer detection using convolutional neural networks. So basically what we are doing is we are trying to assist the doctors in quickly assessing the severity of the Alzheimer disease, which is a kind of neurodegenerative disease. So basically what happens is as the person ages, he loses the neurons in the brain, which causes the loss of memory and such kind of things. Basically, there are various methods for checking if like verifying if the person has Alzheimer or not. There are invasive and non-invasive methods. So basically we are doing is that we are exploiting the power of MRI to assess that if the person has Alzheimer or not, which is obviously non-invasive. So first of all, I would like to explain how we are doing it and what the convolutional neural networks are. So basically, convolutional neural networks are a kind of similar computer based system which is a kind of representation of or a kind of prototype of our brain, how the neurons and the brain functions. So basically it learns from the features and collects the probability of the things which could happen in the future, like if it learns that the specific, like let me show you one example. So these are some sample scans of the brain MRI by classifications. So basically what the convolutional neural networks are doing is they are learning the features of these four categories, which are very mild, no impairment, moderate and mild, so that it can build a data set which has all the probabilistic values which it can verify in the coming future if the person has Alzheimer or not. So this is a kind of different or similar example of how would the Alzheimer detection using CNN looks like. So first of all, we would scan for the large features, small features which are like ages and regions, and after that we will collect that all regions and create a single feature like eye, nose or different kind of facial features, and finally the computer would get a probabilistic value of how a image of person's face look like, and finally it will tag that probabilistic value with the tag which is human. So that's it, how the CNN works at a basic level. Now I would like to tell you about the structure of our neural network. So this is the flowchart of how we are doing it. So first of all, we would have the data set of the MRI, which are already open sourced by the different peoples and agencies. So first of all, we will check if the image is valid or not. Then we will pre-process it and convert it to 128 cross 128 image, and then we will convert the 8-bit image to 2-bit image for decreasing the resource usage. After that, we will use the softmax function, which is a kind of function which decreases the complexity of the image to, like, if the image is of somewhat 1000 bits, then it will convert it to 1/4, which is 250 bits. After that, the image is fed into the CNN, and the CNN will extract the features and probabilistic values, which are then tagged with the specific severity of the disease. After that, it is collected in the dataset. So that's it. Now let's move on to the coding part. Okay, so I would like to explain the training part of this code. The most important part of this code is this one. We are using sequential model for sequential CNN, which is like like the image that I already shown you. This is the sequential model. We could also use parallel model for increasing the training time and decreasing the training time and increasing the efficiency. So what happens here is that there are 3 convolutional blocks. Each convolutional block will separate some features and combine them. After that, the max pooling is applied. The max pooling is basically downsampling. Also, dropout layer is so that the learning could be non-linear, so that the model would learn all the different types of, like, as you know, the things in nature is not always linear. It could be non-linear also. So that's the reason we are using the dropout layer, so that it would be realistic. If some features are not present, then how would the MRI images would look like. So that's it, the dropout layer. After that, we have fully connected layers. The fully connected layers is basically the matrix which are flattened, and now they are getting converted to a single value. Like we are converting an image which is a matrix into a single probabilistic value. So that's why we are using dense or fully connected layer. So that's it. That's the main part of our program of the training. There are also few training enhancement methods which we are like avoiding currently. So okay, now I would like to train the dataset. So this is how we are going to train the dataset. Sorry, that's the wrong directory. Okay, so now the training is going to start soon. Dataset has been loaded. Now the training has been started. So since I had already informed you that this is a very resource intensive work and it will take very long time. So now I would like to stop the training and use the old already trained dataset, which took almost like 40 to 45 minutes for me to train. So I would like to delete the latest one, copy the older one, and now we are going to test how the dataset is performing. So since this is a old trained data set, so it will ask me about, now currently it is loading the data set. Now it will ask me how many images I want to test. So if I would like to test all the images which we can test, then I would just press enter. Okay, now it has tested all the 1279 images in 4.8 second, which is almost like 3.8 millisecond. Out of that, the total correct images are 12,1246, which is roughly 98.83%. Okay, so now finally we have also generated the classification report, which is a F1 score. So F1 score decreases wherever the detection rate decreases. So you can see that the F1 score of mild impairment is 0.99, very mild 9.98. We have got almost ideal case in the moderate impairment detection. And also we have generated the confusion matrix of the final testing. So I would like to tell you the confusion matrix of how the dataset has performed. You can see that it has detected 175 images and 0 false positives. Whale images here in moderate, 638 in no impairment, but there are some false positives which are 9 images. Also 439 in the very mild category with 4 and 2 false negatives. So that's it. Also I would like to tell you the web page. This was our web page which we had built. We can upload the image here and press analyzation. After analyzation, it would tell that if the result is mild, threat or whatever. So that's it. Thank you very much.